Well, welcome everyone to CG webinar stroke seminar number 354. And you're in for a treat today because we have a really great presenter, Ravinder Sidhu, and I'll introduce her in a minute. Now, Ravinder is an associate professor at the School of Education at the University of Queensland in Australia, and she's interested in the governance of mobilities. She's authored 2 books and several major journal articles on related topics of international student mobility and the forced mobilities of refugees and asylum seekers. Her work is marked by a substantial theoretical engagement. And I must say, if you don't mind me embarrassing you a little, Ravinder, very high quality of writing, and is very widely cited and used as a result. So we look forward to your contribution to us today, Ravinder. The screen is yours.
Thank you, Simon. As always, a very generous introduction. It's very nice to be here, even if it's close to 11 o'clock at night. So let me launch in, and I look forward to the Q&A because it's always helpful to get ideas and feedback from people. So let me launch in. And so I usually start this presentation with a good news COVID story, if that's at all possible. And the good news story, of course, is when scientific mobilities or scientific cooperation, when it works, it's a wonderful outcome. There are open and participatory relations that support collaboration, and the end result is usually some kind of advancement for global humanity. So the science internationalism and the science diplomacy during the COVID vaccine is an example. There weren't that many episodes, but one particular significant episode, of course, was the sequencing of the SARS-CoV-2 genome. And the collaboration between these 2 men, Ed Holmes from the University of Sydney and Zhang Yongzhen from China. And it's been described by both these men in various interviews as a story of collaboration and deep scientific relationships. So they've spent time in each other's institutions in the years preceding COVID. And the story you probably all know somewhere along the line is that Zhang and his team were successful in sequencing the COVID-2 genome, released it to Ed Holmes, who then released it to the entire world. And so we had the global production of this vaccine at a record time. So when scientific mobilities work, they work wonderfully. And this is where things start. But the life sciences, which is what I'm going to be talking about, the mobilities that encapsulate the life sciences, has a more checkered history. I'm just going to spend a couple of minutes talking about the history of the recent history of the life sciences, in particular, the different moves that have led to commercialization or biocapitalism. And the significant events is in 1981 in the US, Ananda Mohan Chakrabarty, who himself had a very interesting genealogy of mobility, having moved from India to the US, obtained the first US patent on a living genetically organized organism, which was a Pseudomonas bug. It was a plasmid, and he had engineered this organism while working for General Electric, and his intention, of course, was to produce a bug that would help in biodegradation, in oil spills. So, you know, really significant thing often amongst these mobile kind of scientific collaborations is there are some kind of narratives of salvationism about whether it's more and better medicines, or in the case of Chakrabarty, some kind of breakthrough that would have environmental consequences. It took about 8 years for him to receive this patent, and it was helped, I think, by funding from large biotech organization called Genentech. I think, you know, the whole move in the US was also assisted by legislation that allowed US universities to retain intellectual property. And I think that's a story most people kind of know. Most people who've read, you know, books on academic capitalism, for instance. And then the other significant event was around 1990, when the National Institute of Health started funding the Human Genome Project. This was a massive international collaboration, again, an attempt to map the sequences of the Human Genome Project, about 3 billion chemical base pairs. So a really, really big job. And it too spurred off a move for strengthening public science, but also spurring biocapitalism. In other words, extracting value from biology. And, you know, I spent a brief time as a young person, many moons ago, actually working in science. I'd done 1 degree in science, and I worked in a genetics laboratory for almost 3 years. So this idea of, you know, innovation, the grind of work before innovation, what moves, mobility in knowledge making, mobility in the care and the cultivation of the self, the kind of political subjects emerging from these mobile interactions has always interested me in some way or other. So I'm going to say a little bit only about the very small scale study that I did to explore transnational mobilities. And I chose 2 cities entirely out of convenience. One was Brisbane, where I live, and where, you know, Brisbane has been, I suppose it's where most of the universities are in the state, and it has a long history here, the universities of agricultural research, again, you know, going back to the political economy of the state. So I chose Brisbane. I chose the university I work in simply because it would give me access, and I chose Singapore, and that's part of my biography because that's where I was born. And there was a lot of activity, policy activity around funding, science and engineering, and Singapore's moves to have a world-class reputation in higher education and in science innovation. So they seemed like 2 good places to start with. And I started with just doing a desktop study, looking at laboratory groups that are headed by principal researchers. So at that stage, at least, a lot of information in the public space, individual CVs, which allowed me to see where people had done their PhDs, their public engagement activities, the kinds of grants they had received, the kinds of collaborations that they were engaged in. I then did a short survey with 28 items, got some biographical information, obviously from the surveys, but also from people's CVs, which helped me to construct an interview instrument, and then proceeded to contact people to find out if they would participate in an interview. Now, it's somewhat, I think one of the limitations of this study, of course, is if you want to see how scientific practice emerges on the ground, or what I was interested in these epistemic living spaces, it's fruitful if you can have access, of course, to observations or ethnographies of laboratories, but there's a lot of, I think there are a lot of complexities around getting access to ethnographies or multiple laboratories. And at that time, I think I just wasn't successful in doing that. I was doing another little small scale study where I was embedded in different life science laboratories, so I could see what kind of work was happening, but not in this study. So this is definitely a shortcoming of this study. So what are epistemic living spaces? Well, this is a theoretical concept that comes from feminist science and technology study. There are 5 dimensions to these epistemic living spaces. There are symbolic dimensions, the systems of valuation that exist. There are social, intellectual, temporal and material structures that mold, guide and delimit researchers' interactions, what they aim to know, the agencies they exercise, and basically how they go about producing knowledge. So this idea, of course, is associated with Ulrike Felt, and she's the person right at the top left-hand corner, and she was she's a theoretical physicist, and she spent many years working in theoretical physics. So she worked at CERN in Switzerland in that large scientific organization. So she brought a lot of grounded, I suppose, experience and insights into this whole area of how knowledge is made. She was also influenced by Sheila Jasanoff, and Sheila Jasanoff's work, as some of you would be aware, around co-production, which sees scientists as social actors, as social beings, and their interactions with the world shaping the kind of scientific practices and activity they engage with. And finally, the work on epistemic cultures by Karin Chatina on the cultural and subjective aspects of scientific work. So essentially, science and technology studies, which was not an area that I actually looked at, not a corpus of existing work, ended up being really very, very helpful. It was helpful because obviously it was engaging with spatial variations in the practice of science, that science happens somewhat differently in different locations. And I had a very old-fashioned scientific training, so that surprised me a little bit. It also engaged with power relations at multiple scales, at global, at institutional, at national, and so forth. And interestingly, it also engaged with coloniality. So it's a very rich thread of work that looks at science and how it functioned as a handmaiden of empire and imperialism, and also the really important role of science in post-colonial nationalist aspiration. So all of this, I think, was quite helpful in my study. Whoops, sorry, I think I'm just raced off there. Okay, so one of the things that drew me to this concept of epistemic living spaces and the literature on science and technology studies is its focus on knowledge making. And a lot of the other research that I think that was looking at, biocapitalization had focused on the economic aspects, the economic critique. And while there's plenty to be said, lots of strengths about this work, it does tend to reduce the scientists to something of this, Homo economicus in search of different forms of capital. And it doesn't pay much attention to the types of innovative knowledge practices that emerge from these mobilities. So I was interested in that. The other important thing about this contribution from SDS is that it recognizes the links between logics and structures of production and social reproduction. So true to the feminist ideal, it looks at the co-production of personal and political. It embraces mobilities as well as immobility, and it actually widens understandings of subject making. It looks beyond the individual entity, and it looks at connectedness and entanglements of places, institutions, networks, the engagements with instruments and multiple different types of others informing political subjectivity. And this is an area I've been very interested in, how international mobility shapes the making of political subjects. And it's an area I still haven't quite cracked. So I'll be looking forward to your questions in Q&A. So when you dig deeply into any type of scientific practice, it is an incredibly moving world. And I shouldn't be surprised, having been briefly embedded in that world, but I am. If I compare it to the kind of world that I move in the social sciences or the humanities, there's a great deal that's on the move. Obviously, there's the mobility of individuals at all stages of their career, but mobility seems to be strongly institutionalized in science. I think far strongly than, stronger than it is, I think, in the social sciences and humanities. So the PhD students, for instance, are encouraged, pushed, supported to become mobile fairly early on in their candidature. There are all kinds of grants and schemes to support them to obviously travel to conferences, but also to make laboratory visits. The very recruitment of PhDs, of course, is a very international process. It involves people moving from one part of the world to another part of the world. And this mobile imagination continues right into, the types of authorships that are encouraged, cross-border authorship. Other things move as well. There's equipment, really, really complex equipment that moves from one part of the world to another. There are animal models, reagents. A lot of large labs also use all kinds of screening services that may be located in another country, clinical trials as an example, the purchase of tissue cultures and so on. So it's an area, I don't know how it functioned over COVID, but I imagine there would be lots of difficulties because there's a cross-border mobilities of techniques, ideas, and people, and obviously, or as well, the mobilities of different policy imaginaries, further back looking at modernization, then the discourses of academic capitalism and knowledge economy, the discourses around entrepreneurial universities, the assembling of the world-class university ranking system, innovation ecosystems, and so on. So it's very much a world on the move, and that's probably happened for quite a long time. Certainly, if you read Science and Technology, STS journal, you find that there's some fascinating studies during colonial times around how public health policies were framed and the scientific innovations that emerged at that time. So it's got a long history of that. So I'm just going to share some vignettes that emerged from interviews about how people move. So probably one of the first steps is choosing a knowledge destination, where to do your PhD, and a whole range of reasons accompany this movement. So this is a scientist in systems structural biology. And he's talking about his movement from what was then Yugoslavia to Texas. It's a bit of a culture shock there. And he's currently based at the University of Queensland. He's been there for quite a long time. But here he is talking about how he, very rational, very, obviously clear ideas about who he wanted as a PhD supervisor. And he says there was no macromolecular crystallography lab in Yugoslavia. I wanted to get trained in this area. I knew about Hans Dyson-Hofer, who later became my PhD supervisor. And Hans at that point was located in Germany in the Max Planck Institute, and he had recently moved to the US. He went on to win a Nobel Prize. So this young person then followed him, and he wrote to him. So, one of those very motivated PhD students who had a clear idea of what he or she wanted to do, wrote to a prospective supervisor and received a positive response. And so he goes on to say that one major reason why he chose the US, obviously because Hans had moved there, but also it had an institutional setup, an established system for getting people from overseas to come to do a PhD. And he made this point several times in the interview. They're heavily reliant on these types of individuals. It's a streamlined process and knew exactly what I wanted to do, and off I went. A very similar point of view, also a young person from Eastern Europe who moved to the US in the 1990s, and he goes on to say, choosing the US was a very important move for me, not only scientifically, but also personally. It was a dream, this American dream of mine. I saw the US as the beacon of freedom and opportunity, and a place to do top-notch research. Bulgaria was a communist country then, and so I had this dream that I would go to the US. And I think what's interesting about looking at these attractive destinations that people move to is doing a space-time analysis. So, most of the people that went in the 1990s and into the early 2000s, had a memorable experience, and it shaped them as people. So here's another research fellow based in Australia. He said, scientifically, there was simply no limit to what I could achieve in the US, and the only reason why he returned to Australia was for family reasons. And he went on to do very well in Australia, but he certainly saw the US as a formative experience. But some of the younger postdocs that I interviewed, or people who were, at mid-career level, were starting to have a different view of the US. So this is, 10, 15 years later. And so this is a young German molecular biologist who I interviewed in Singapore. He said, I would have had difficulties getting a green card. I was not married, and my partner and I had no intention at that point of getting married. And as a teenager, I had been influenced by, I had a very negative view of the US and its foreign policies after the Iraq War. Another German neuroscientist based in Australia talked about the US as just work, 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 and work. And this last comment from a Spanish immunologist, also based in Singapore, she said, my husband was at Princeton and he felt that working in the US was like being eaten alive. So it had become, a fairly hyper-competitive, and this was not attractive to some postdocs if they had other options. I think a point I made earlier about using this idea of epistemic living spaces is it allows you to look quite closely at the kinds of knowledges and epistemic border crossings that take through these mobilities. So this is an excerpt again from an Australian scientist who had spent time in the US, and he's a cell biologist, and he's talking about this idea of working quite closely with people in theoretical physics, for instance. So to understand the tissue mechanics, we got theoretical physicists to help us out. They bring powerful conceptual frameworks. And the virtue of working with theoreticians at that level is that they can frame the problem at the level of granularity which biology needs. And then he goes on to say that lots of molecular biologists feel uncomfortable with the high-level theory that ignores these fine-grained biological details. But for him, because he was so experienced and he knew a lot about cell-level details, it was okay. I don't care about the details. We can add the details a little later. And he goes on to say we've made a lot of progress in identifying many of the molecules in molecular mechanism, but although we've made a lot of progress using all kinds of interdisciplinary tools and fairly sophisticated equipment, so that we can see how the signaling between cells takes place, you have to now deal with a much greater level of complexity, which gets even greater when you think about the challenges of how cells interact with each other to form tissue. And so you need even, better tools, and we don't have those tools. And he was working with the cytoskeleton. I won't try to drag up my terrible knowledge now of cellular biology, but the point here, I suppose, is there's a lot of experimenting, there's a lot of sort of border crossing within these disciplines that's taking place. It's changing the disciplines. And many of these interactions happen when people cross geographic borders. I think the other interesting thing too is, unlike the kind of material that comes out from policy makers or political speeches, most scientists are remarkably low key as they're talking about the opportunities of their work, but also their challenges. So these, even people that are doing translational work, work that has some kind of entrepreneurial sort of outcome at the end, they're remarkably grounded. There isn't a lot of hype there. There's hope, obviously, but it's not inflated, it's not amplified, in the way you see perhaps policymakers or politicians speak. And so here, this is another person, Brisbane-based biologist, talking about biotechnology, moving into biotechnology as a result of being in a PhD laboratory where there was a lot of cross-disciplinary work. Biotechnology is multidisciplinary, and he had, after that, set up his own company and was quite entrepreneurial. And in his lab, he talked about having molecular biologists, protein chemists, and physicists. We examined the technological aspects of magnets, electronics, immunochemistry. It takes energy and activation for people to launch into different disciplines, but you need intrinsic curiosity and a little bit of confidence to venture into a discipline you don't know. As a group leader, the challenge is to get people talking to each other. So many of these labs are very, very international. If I compare the internationality of some of these scientific labs to, say, my own school, it's really quite stark just how much of diversity there is, cultural and linguistic, in these laboratories. But it's not easy doing this work. I think that's the other thing the interviewees I spoke to maintain. It's quite hard. You have to develop new conceptual tools, learn new concepts so that you can actually talk the language of, and it is almost like a language of a whole different lot of collaborators. And this is a Singapore-based computer scientist who had trained at Stanford. It's hard. You have to talk the language of biology. I look at the data at all the stages. I go into the wet labs. I explore what they're doing. And then I come up with problems that can be solved by using sophisticated computational analysis. Lots of possibilities here, modeling how tumors might behave, but also obviously some limitations. I think like academics everywhere, we probably feel we work really hard. Like we never actually switch off. I'm aware it's approaching 11 o'clock or just after 11 o'clock, and I'm still working. And I have an 8 a.m. lecture. So, but before I feel sorry for myself, I'm just going to share some of the kinds of temporal regimes, the rhythms of scientific work in the life sciences. So here's an Irish molecular biologist. I'm in at 8:30. I leave around 7:30 p.m. I work weekends as well, maybe about 3 to 4 hours on the weekend. He had a partner who was not impressed with all this hard work. I also do reading at home, and when lab work is in full swing, I'm in the lab till 10 or 11 at night. And the scientists who were men were very, very clear that there was enormous advantage in having a stay-at-home partner, although they went to great pains to emphasize to me, perhaps because I was a woman, that this was a choice that their partners had made. There'd been no pressure on their part. And so this is the European scientist, very successful, based in Brisbane. He says, it's an unfortunate thing for me that my partner chose to become a full-time mom. So she's at home. It's made it much easier for me to do some of the things I need to do in my position, like traveling. It's much easier that she can handle things. And then he goes on to say, I really admire people where there are both parents working with children of this age, and he had young children. Okay, so there's obviously those temporal regimes, but there are also, I guess, different sorts of spatial borders that can be enacted when you move to a different city. So this is an Indian chemist who interestingly had left India because of the very strong anti-Islamic sentiments. So he had come from Ahmedabad, which is where the current Prime Minister of India comes from, and was chief minister. So he was very, very careful, chose his words very carefully as he was talking to me. So he left to India because it was not a safe environment, he felt, for someone like himself, a Muslim man. And he won an award from Germany. I think it was a Humboldt Foundation fellowship. And unfortunately, he was sent or went to East Germany, where security was a big issue. And so moving around the city freely was something he felt really uneasy about with a young family. So he's describing the police conducted interviews and seminars for us. They were invited by the university because we live in international housing, and this housing had been threatened by neo-Nazi local groups. We basically told about what parts of the city not to go to. If you want to go there, go on weekdays and also go with local people. You're simply not safe. And so after finishing our contract, we decided to move. And he eventually ended up in Singapore, which, it is certainly has a kind of an authoritarian system. It's not a liberal democracy by any measure, but one of the attractions of living there for people was the safety. Yeah, just the safety on the streets, and the safety from xenophobia and so on. The thorny issue of gender and mobility, do lots of women move? I think, particularly in the life sciences, it's fair to say there are a lot of women who study in this broad area of the life sciences. There's a pipeline with quite a lot of women, but by the time you look at the laboratory principal researchers, who heads laboratories, who wins awards, there are obviously fewer and fewer women. And women were very clear, women in science, about the difficulties of managing care responsibilities with work, access to affordable childcare was flagged as a problem. At that point, the women who worked in Singapore told me that there were no formal carer leave or parenting leave provisions. I think that might have changed by now. And so it was very difficult for them to be able to nurse their babies and continue working at the same time. Dual career couples found themselves with in rare cases, both their careers progressed well, but in other cases, one spouse had to trail the other, and it was more likely, at least in my sample, for that to become the wife. At that point, there were immigration restrictions on wives working in Singapore. So, if the husband had received a job offer, the wife ended up having to stay at home. And this was a policy, a domestic policy that came about because there was a lot of angst about the Singapore government investing very heavily in what they call talent recruitment from overseas. So to appease the public, they had this quite punitive rule. So it depended on when you came, but there were immigration restrictions. These interviews were done before the famed Me Too movement, and women spoke openly about some laboratories where there were, difficult work environments. There was clear sexual harassment, including some very, very famous institutions. You were expected to go out drinking with the lab head, and if you didn't, or you hung back, you didn't get a look into the kinds of collaboration. And in some labs, of course, women spoke about masculinist norms in the styles of communication and leadership. One question I asked them was, well, what does it take to succeed in science, to be an internationally reputable scientist? And the words ego and arrogance came up really quite a bit. So this is a woman scientist talking about, who's had a very successful career, and hers is a fascinating biography, because not only did she manage to combine family and success, conventional success in science, but she also came from a working class background. So she was the first in her family to go to university. So she was really quite exceptional. And she's talking about women in her lab who are just not willing to move overseas because they have family commitments. They believe it's going to jeopardize their relationship. And the constant tendency for women that she was supervising, mentoring women, are often willing to take a second best option if their partner has something good. And she ran these mentoring networks, and she said, this kind of balance is not good for either of you. That's the advice she was giving. Your career has to be considered as of equal value. I don't know what proportion of marriages break down. What on earth will you do if you are in a substandard job, if your marriage fails? So this was, her contribution to try to tackle some of those problems around women not wanting to go overseas or coming back what she thought was a premature time. So amongst these great stories of border crossings and new knowledges being built, there is, of course, it's a highly stratified field, and it has to be said, I think, that in an entrepreneurial setting where there's funding restriction, postdocs who are critical elements in this whole research infrastructure. They are so incredibly important. Their working conditions have really worsened over the years, and many of them spoke of precarious work and in a kind of indefinite waiting to get a secure position. So this is a young man in some aspect of computational science, and he's saying a career in science is like a career in acting. People at the top earn a lot, it's long hours and not much of a salary. And his wife was very keen to have a second child, and he just said, I don't have the time or money to provide support for a second child, and this just wasn't what I intended when I entered science. And the final quote is it's not a not so young person, a woman. She says, I'm in my 12th year as a postdoc. I was at MIT for 3 years. And when I came back, I went to, these are all fairly prominent institutes here in Brisbane, the Diamantina Institute and the Institute for Molecular Biology. And then she decided that she was going to be archived as a postdoc, and she was going to leave science, and subsequently has left science. And aside from the insecurity was the sense of, I don't want to be a group leader, because I got into science to do bench work, not write grants and do a whole lot of administrative work. I do want to say that when you look at the citation metrics of many of these scientists, especially the postdocs, it's incredibly impressive where they publish. Their citation metrics are pretty amazing, but it hasn't necessarily enabled them to get positions. So obviously there's a whole lot of other stuff going on around securing position. So I'm going to conclude now. I don't know how much of time I have. Sorry, Heaven. To say that one of the positives of international mobility, will mobility continue in the future? Well, I think yes, it will. It simply has to, because of the curiosity that people have, the flourishing of different border crossings, epistemic border crossings through this mobility, through this people-to-people contact. But it's really important not to see scientists as, these highly skilled people that have somehow frictionless mobility. I think, there's something of an industrial imagination of nation states when it comes to investing in science and securing some kind of rate of return from translational science. That makes it quite difficult for scientists. There's obviously the market-driven promissory sciences, but there are opportunities there, but also limitations, which makes it difficult to do basic science. And because scientific endeavor is so incredibly complicated, I think earlier I said that scientists, there wasn't a lot of hype, there was hope and there was curiosity, but scientists were really, really clear of how difficult it is to answer some of the questions that they want to answer. And clearly there's been a lot of work written on the neoliberalization of the culture of universities, and this division between scientists, further up, or administrators further up the career ladder, and those at early career and mid-career level. And the solutions obviously are going to require some kind of policy input to mediate these tensions, these borders and boundaries, and they have to be widespread. I mean, I think they've been attempted at different times, but there's a lot of policy impatience as well. So policies are put up and then they're rolled back or removed, whether it's in taxation, immigration, clearly higher education resourcing, and policies around intellectual property. Okay, I'll leave it at that, and I'm very happy to have some questions.
Thank you, Ravinder. There's a lot there, and very, very interesting. We've got about we've got a bit less than 15 minutes, and we've got a question coming through from Sayong. I might ask you one first.
Yes.
I think there are a lot of things in your presentation that resonated for many of us. The stuff about gender and you know, two careers and when there are children. My observation, for what it's worth, is that it works when there's a third caregiver, you know, like a grandparent in the mix. It's pretty hard to make work otherwise. And in the cases where women are really doing well in academic life, sciences and social science or humanities, you know, able to be very productive, there's usually a very strong commitment from the male partner there, or the partner there, the other parent, male or female, there to you know, to sustain most of the childcare. But it's interesting, isn't it, that whereas in patriarchal families, men seem to be able to turn off child rearing, I don't think it's quite possible for women to do that at any level. And I remember, you know, one of my colleagues who's a really productive, highly respected sociologist, saying that you know, that although her partner's wonderful in putting so much time into childcare and child rearing, when she comes home, the girls just want to be with her. You know, it's sort of really hard to completely, you know, if you like, neutralize or equalize or make equivalent the you know, the role of the two people. My question is going to be about kind of a bit related to what I'm doing at the moment on global science about mobility. And there's some evidence that people are doing their most original cutting edge work when they're in nested local communities and collaborating there, and that being the main sort of driver or source of the new ideas. Often it's cross-disciplinary and so on. Whereas, you know, a lot of really good and important work's done through collaboration at a distance. The local collaboration seems to have more epistemic power, if you like, in some respects. So people want to head towards these nodes where things are happening, but of course, these nodes are not equivalent across the world. So do you have a strong sense from your inquiries that people really want to be in this sort of metropolitan centres? I mean, how important is that?
I think it's like an obligatory point of passage that they have to spend, and at least in the sciences. I had no idea that so many grants and schemes existed. There's small scale ones in institutions to send out their PhDs, and that they finally of doing their PhDs were organizing for them to have these laboratory visits, so to secure a postdoc. They're small bits of money and they come about in very, very interesting ways. So there's actually an institutionalized system to get them to move away from their original, if you like, you know, nested communities and to move further away. That seems to be institutionalized in science. Great work happens amongst these local collaborations, local communities. You're dead right. You know, you have pockets of excellence, and it's just a matter of people having access to resources. And interestingly, you know, the people in my sample who had been to the leading laboratories of the world, you know, the Salk Institute, the laboratories at MIT, Cold Springs Harbor, Cambridge. So the really big names had good experiences, but there also were people who didn't have very productive experiences. So, you know, the priorities of the lab might have changed, or the lab head might have left, or was having relationship difficulties. There were all those very human elements that come into it. So I agree with you. I would say this idea of the local, the nested communities, the work that happens in these communities is enormously important. You know, it's important for the scientific literacy of every country, having that sort of know-how, giving people opportunities, and they would solve potentially some of the gender problems as well. If you know, people felt that they could actually stay on and have opportunities close by, rather than going to another part of the world just for resources. I'm not sure if I've answered your question, Simon, but I do want to make a point here. Someone is taking care of those children, or you know, that elderly parent. And so in these innovation ecosystems, it's really important to keep that in focus. Someone is taking care of somebody. And in Singapore, where there were, you know, paid domestic helpers is just so commonplace. There's an army of domestic helpers that keep these high-tech, super-duper careers going.
Another clue to the Singapore miracle. That
Yes.
Exceptional living standard, that exceptional per capita income,
Yes.
enables
Yes.
the exploitation of the unequal
Absolutely.
labor force.
Yes.
Precarity, another topic which you've touched on. One of the things that struck me about that is that it's not the same everywhere. You know, that it seems it's an Anglophone disease without doubt. But not quite the same in every Anglophone country, and very varied in Western Europe and East Asia. So that's a topic to explore further, I think, because precarity is just such a major problem. Let me bring in our two major questions in the chat, and I think we'll have both questions taken together, and then allow you, Ravinder, to respond, and that'll take us close to the end of the webinar, I think. So So-Young, do come in first.
Thank you very much, Simon. And thank you very much, Ravinder, for your wonderful presentation. So my question is about disciplinary differences. That you talked about very good example about science and STEM field, including theoretical physics. I wondered if the topics about epistemic cross-border crossing and the mobility, academic mobility, would be different across fields. For example, like in STEM field, maybe you talked about more institutionalization of this field, but what about the nature of knowledge itself? For example, STEM field would be more universal than other like humanities and social science that is localized and conceptualized. Yeah, I wonder what you think about that. Thank you very much.
Now, before you answer, Ravinder, I'd like to bring in Jorge Ulrike Delgado. So please come in, Jorge.
Good morning from Pittsburgh. Thank you very much. Very interesting, really, your presentation, and the topic is something that I'm really interested. So my question is about what happens with these scientists, either scientists or, for example, PhD people pursuing doctoral education, when there are differences in epistemic developments, knowledge, methods between countries. I just put in the chat an example what happens, for example, in construction and engineering between countries. So how, if you've found anything like that or related to that. Thank you.
Okay, two sets of questions there.
Okay, let me see. So I did have some interviews in engineering, which is a global discipline, by the way, and people were doing some very interesting work in bioengineering, for example, but I didn't look at construction. But just from anecdotally, you know, engineering is one of the most globalized disciplines, and people move between countries. I would be surprised that there isn't some kind of collaboration, but I can't really say what kinds of collaborations were taking place in construction. I do know that bioengineers work with, you know, materials scientists, for instance, people, engineers in materials, were working very, very closely with STEM, you know, people in the STEM areas around all kinds of things, you know, whether it's prosthetics, implants, and so on. But I can't say anything more about that. I just would need to do much more study, but it's a fascinating area. And the other question, Sidhu, is, you know, even when we talk about STEM, I mean, STEM's a very convenient acronym. It encapsulates science, technology, engineering, medicine, and the sheer disciplinary complexity, and within each of these broad, you know, fields, if you like, there's just so much of complexity. I think that I actually felt that these scientists in STEM, if you like, were doing far more interdisciplinary collaborations than I certainly was, or my colleagues in education. We tend to stay, you know, perhaps with the humanities, perhaps a little bit of philosophy, doing fairly similar kinds of things. But these people were doing really different things. If you're a cell biologist and you start working with someone who's in theoretical physics, it's mind-blowing how separate those disciplines are. Not sure if I've answered that question either. I think it's certainly an area to do a lot more research in. And it's a kind of research where, you know, you do need maybe big data to find out where people are going, what kind of, you know, metrics, identities they have, and their collaborations, but also some fine-grained data to actually watch what happens in laboratories and to talk to people in these laboratory settings about how they make this knowledge, this new knowledge. Yeah.
Well, thanks very much, Ravinder. Really interesting work, and we're looking forward to more from you and more published work from you on this in this topic area.
Oh, you could be waiting a while on that one.
but when it comes, it'll be good, and you know, and enlightening. So as it has been today.
Thank you, Simon.
Colleagues, our next webinar is coming from Hong Kong, coming from Ling Nan, and coming from Ka Ho Mok, who's almost a regular these days on the webinar program, and he's working with his colleague Bahua Yu, and they're going to talk about what's happened with international education amongst Chinese students and Chinese families since the pandemic sort of began to ebb, and how the pattern of choices and movements is changing. In particular, they're going to present evidence that opportunities for immigration and overseas employment are no longer significant, and whereas costs and global rankings and Chinese employment prospects on return are quite instrumental. So again, Ka Ho Mok, Hong Kong, on student mobility, particularly in East Asia, and that'll be interesting. Our series on the future of global academic mobility is throwing up a whole range of topics and discussions, and there's quite a bit more to come. We're going to continue it really until late in June, interrupted somewhat by a week beginning on the 22nd of May of CGHE conference and the CGHE webinar conference, which is the international, the online part of the CGHE conference, is on Tuesday the 23rd. So we do look forward to seeing you for Ka Ho and Bahua, and that's next Thursday, 2 days' time. And we also look forward to seeing you at the CGHE conference, the online conference, on the 23rd of May, and on the 22nd of May, you'll be able to receive the live stream version of the face-to-face conference of CG in London. So we look forward to seeing you all then. And until then, it's bye for now. And thanks again to Ravinder.
Thanks, everybody. Bye now.